Well, hello everyone. Thank you for joining us this afternoon. Pretty gray and rainy here in Ontario, but I'm sure we have guests from across the continent, so welcome everyone. And hello, my name is Eric Teacher, and I'm the National Specification Manager here at Lightline. I'm primarily responsible for support to our Canadian network, but I'm happy to always hear from our American friends. Laura can provide contact information, or you can reach out to Shauna and Miriam for if you'd like to touch base personally for some project that you may be working on and need some help. Today I'm going to show you, we'll walk through all of the considerations to do a basic layout. We'll be covering things like key terms. We'll talk about the information needed to do the calculation. So all of the basic requirements. We'll be looking at our photometric report and each of the fields of data explained briefly so that we all understand how the information is used and derived. We'll talk about how the photometric report is created, what equipment we use, and how an IES file is created and why an IES file is useful. We're also going to talk about a little more about IES and the recommended light levels that they have developed over the more than century that they've been around. And finally, we'll talk about what a layout can do for us, what information we derive from it, and how to do one. And we'll be going through the visual basic interior tool. It's a free online utility that anyone can use to do a layout with really anybody's fixture. It doesn't have to be Lightline, but of course we're happy to teach you how to use this tool in some clever and creative ways. I'm going to turn off the video so that you can focus on the presentation content in the slides. I will narrate as we go, and when we get to the point at which we are doing the hands-on visual layout. Sorry, I'll be doing the hands-on visual layout. I'm going to ask Laura to, at the raise of anybody's hand, to open their microphone so that they can ask the question and communicate with me directly through audio. So enjoy the presentation. So some of the key terms, and I'm quite certain that that I'm talking to an audience of lighting professionals. You all know these terms intimately. You've been in this industry, but for those that don't, we'll just cover the basics. So illuminance is the flux that falls onto a surface. So the light that we measure on the surface at which is important for us to measure. So if it's a hallway, we might be measuring at the floor. If it's an office, we'll measure at the desk. Either way, illuminance is expressed in two different metrics. One is the foot candle, and the foot candle is defined as the light emitted from one candle or one candela that travels 1 foot and hits a square surface or a surface area that is 1 foot square. So that is the total lumen, the light that you would get in a lumen. The same measurement can be applied in a metric equivalent, which is the lux. 1 lux at 1 is 1 candela at 1 meter over a 1 meter square area. What we will focus on is the foot candle and illuminance, because the foot candle is how the Illuminating Engineering Society provides guidelines for light level targets for all kinds of various spaces. Another term to be familiar with, although it's not practically used in lighting layouts, it's important to understand that choosing a source with an appropriate CRI or color rendering index can more faithfully reveal the colors of the objects in your space. I should mention that we will make this presentation available so that if there's too much content to be read during the time I'm on that slide, don't fret. We'll have a PDF copy available for Laura to send anyone that requests it. Correlated color temperature, CCT, defines the color properties or the warmness or coolness of a light source, and is measured in degrees Kelvin, which is a measurement range that is used in scientific measurements for measuring very high temperatures. So a lower color temperature is considered warmer and will be redder in its hue, and a cooler color temperature is higher and will be bluer in its hues. Color temperature, by the way, can also provide a slight edge in efficacy for LED light sources. The higher the color temperature, generally, the more lumens you will produce from the exact same source than from that source with a lower color temperature, such as 3000 Kelvin. And the reason for that is that phosphors have to be layered onto an LED in order to create higher CRI, and color temperatures also have to be scrubbed out. So the blue content has to be scrubbed, so more phosphor is layered on. That's why lower CCT sources are less efficacious than higher CCT sources. Anyways, now on to photometric reports and IES files. I should note that having worked for a number of manufacturers over the course of my career, spanning a little over 25 years, I have only come across one or two manufacturers that produce this type of data and publish it. And I'm very proud to say that Lightline is one of the very few manufacturers in our sphere that produces this kind of extensive granular information and publishes it for virtually every product that we make. The way that a photometric report is generated is by using a 2-meter integrating sphere. Basically ours is located in the laboratory in Richmond Hill, which is a satellite ETL certified lab. It's a level 3 certified laboratory. We do thermal testing, we do electrical testing, obviously we do photometric testing as well. We also do wet location testing. So photometric reports are generated when a fixture is placed inside a photometric sphere that is 2 meters in diameter. It looks like a very big green egg barbecue, only it's lined with this flawless white reflective coating. And the Class C goniometer, which is also within our lab, is in its own black room, completely blacked out. And the Class C goniometer is what a fixture is mounted on to get the angular distribution that we publish on our reports. But we'll go through that in more detail. The image you see on the right is a notepad of the text in an IES file. Unless you have an IES file viewer, which is available online as a free download, there are a variety of them, just Google it. You will only get this kind of information if you try and open an IES file without an IES file viewer. So it's just a bunch of data that comes from the equipment, the Class C goniophotometer. And with that testing completed, we can create all of these cone diagrams, beam angle distributions, and so on. So let's dive in a little deeper into the photometric report. Basic elements include the efficacy. So our lumen per watt efficacy for the light source. In this case, we're looking at a 2x4 edge luminaire, and it's delivering 113 lumen per watt efficacy, which is fantastic for this type of luminaire. Next, we show the light quality. So that's expressed in CRI. 84.4, a very, very good comparison to a center basket LED trough for very similar distribution, but the light quality at nearly 85 CRI is quite exceptional, certainly more than most products that are installed in offices today. Color temperature, we have a lot of color temperature selectable products. This happened to be a 3500 Kelvin, and you can see that there's a 66 Kelvin deviation. In this type of testing, you're allowed to publish within 150 degrees of the, so that's the deviation factor. So this is actually very, very close to 3500 Kelvin bang on. Angular distribution, here we're showing the field angle and the beam angle. The field angle is the total light output, and the beam angle is comprised of 50% of that light. So think of a pool of light where you have a brighter concentration in the middle. Whatever would amount to 50% of that concentration, that is considered the beam angle. So in this case, it might be 70 degrees. 67 degrees. The field angle is the rest, everything that trails out to the edge, the remaining 50%. And that's what we illustrate for every one of our products. Field and cutoff angle data is just a summary of everything that you see that's graphically illustrated. Of course, we show you the test luminaire that the photometric report applies to. An intensity cone diagram is actually quite useful for the novice to be able to take this information and know, given a mounting height, exactly what size the pool of light is going to be. And if you want convergence, if you're looking for uniformity, then you can use this to define your spacing criteria or to get very close so that your pools of light can cross. So depending on your height, your pool of light, you either want 50% of it overlapping for absolute uniformity, or you may want drama, you may want contrast. So we want pools of light, and then we want our our recessed lights maybe centered on 7 or 8 foot centers, so that we have these very distinct pools of light that provide contrast. And finally, of course, we publish our own data at the bottom of most of our documents. Moving on to the second page of the photometric report, this is the light planning area, and here we have the zonal lumen summary. This information shows us where the light is falling at which angle, at which vertex. So based on this, I can tell that 61% of my light falls between 0 degrees and 40 degrees, and that if I go to the 90 plus, only 3%, 3.05% of my light is going above the horizontal plane, typically our ceiling, which means that there's a very, very low uplight component, but it's there, 3%. The isolux diagram defines the beam shape that is going to be distributed from our luminaire. And it also shows you the intensity concentration in those circles as they expand out on a grid that is got measurements in meters. The coefficient of utilization is generally no longer used because most software provides this kind of very quick layout utility without having to sit there and crunch all kinds of formulas. But the tables are there for experienced designers who want to use the data to very quickly define how many fixtures or what volume of light is needed for a space. The luminaire budgetary diagram is a simpler version of this, where room cavity ratios don't need to be known. All you really need is your mounting height and area. And based on your mounting height and area, you can figure out how many luminaires you will need to light that space to and we give you this information to 100 lux, which is 10 foot candles. So based on these charts, you can determine that you may need 8 lights for a space that is 320 square meters with a mounting height, and I'm sorry for the eye chart here, but it's expressed in meters, 4 meters, 5 meters, 6 meters, and so on. And there's a nice little chart. So when you look at a full photometric report, this is very legible. When we get to the colored detail area, what you really need to know here is that we've summarized a couple of different types of metrics. So the chromaticity diagram shows us what the black, where we are on the locus for maintenance on the black body, and then we have a close-up. Close-up defines, no, yeah. So here, if we zoom in at 3,566 Kelvin, we see that we're actually located ever so slightly off the black body towards the pink orange, which means that it is possible that there would be a mild, probably indiscernible pinkish hue. But that's what the zoom function does. Then we show you, well, that was the zoom function, sorry. The TM30-15 graph Normally, I'd be very excited about showing you TM30 information because from what I understand, not only is the rarity of photometric reports so pervasive in our industry for manufacturers, TM30 is virtually not being published by any manufacturers yet. And this is the newest metric for being able to derive the quality information. I'll have more on TM30 shortly. Anyways, this chart used to represent the data that was generated by this IES test method 30 that was developed in 2015. We're going to be removing this chart because we're going to have an entire page on TM30-2018. So the newest revision, newest iteration of that test methodology. And you'll see that it's been quite significantly enhanced. CRI, when we start talking a little bit about TM30, you'll understand that TM30 was developed to replace CRI for LED sources. CRI was a terrific measurement for traditional sources, incandescence, halogens, fluorescence, compacts, and so on. For LED solid state sources, because the source starts its life in such a very different way, measuring its performance attributes has been more complicated. We'll get there. So the CRI graph is just illustrating that our source is 84 CRI, and it's actually giving you those first 8 pastel colors, which is what CRI is measured on. Interestingly, you can have a high CRI source or a higher CRI source such as this with a relatively modest R9, which everyone raves about these days, erroneously, I might add. R9 is useful for skin tones and for rendering extreme conditions of red, like in a Coca-Cola showroom. But aside from that, this level of R9 is perfectly adequate. So our reports will continue to have CRI until it meets its maker. CQS was another method, another platform that was developed to measure performance of a light source. It was the color quality scale, and again, it was designed to replace CRI, but it was never really adopted. And TM30 will likely be the champion in this particular battle. This data is just a tabular summary of what you've seen graphically on the page. So I won't profess to provide enough information for you to become TM30 experts, but I can explain to you a little bit about TM30 and why it's interesting as a new benchmark for measuring color quality of LEDs. It was developed in 2015 and recently updated. And so if you look at the data from the previous slide on TM30, which was this, just covering 16 different hues. When we go to TM30 2018, we've expanded that to 99 different colors or hues. And those 99 hues are binned. So they're put into subcategories or called hue bins. So TM30 allows us to provide measurements on a fidelity index and on a gamut index. Essentially, fidelity and gamut are your indicators for vividness or saturation. As I mentioned, there's a lot to know about TM30. So let's go through some of the information that we are already illustrating on our photometric reports, those that have been recently updated for TM30 2018 data. So here it is. Here's your fidelity and gamut index, and this defines vividness or saturation. And once you start to understand the basic workings of TM30 and what it's designed to provide for the lighting designer, then you'll begin to understand what these numbers mean. Chroma and hue shift by hue bin is a tabular summary of what we're seeing down here. The RFRG, so the fidelity and gamut plot, this time is on a Planckian locus. Now, essentially, this point right here defines the ideal source. So as we get closer to 100 on each scale, the horizontal and the vertical scale, this is utopia. So this is sunlight. Sunlight produces every spectrum, renders everything beautifully, and provides vividness and saturation always. The next part is just to describe the graph. So again, we've got the fidelity by hue, we've got chroma shift by hue, and we have color vector distortion graphics plot. So a color vector graphic is something that takes the perfect round circle shape and then shows you where your light source is either deficient or over efficient. So in this case, everything is constricted over here in the pinks and the blues. So we're going to lose a little bit of our pink blue hues here, or the ability to render those. Also over here in the greens and violets. But down at the bottom, we're going to oversaturate in this area of the color spectrum. So it's just a very quick graphic illustration as compared to the perfect circle, which would be utopia, where there is no shift in chroma or fidelity. And then there's the fidelity index by sample. So this is every spectral wavelength in the visible wavelength grouped into nanometer ranges, and then shown on a color palette. And this is where your source's peaks for performance are in these colors. So you can see that this is a discontinuous spectrum. It's not like what we would have been accustomed to seeing in a halogen light source, which would have just kept ramping up into the infrared. We'll show that later. But that's what we're adding to all of our photometric reports. It's a full page on TM30 information, and coming soon, we're adding one more element, which the lighting design community has asked for, and that is spectral power distribution curves. This is a really important aspect. Now, it's not going to look like this. Typically, you've got a more granular scale and a bunch of spikes. This is just for presentation purposes. So we will be adding SPD data to our photometric reports. If you need that for any of our products, we can provide that to you today. All right, and the last page that you find on our photometric reports are the UGR values. The glare evaluation for unified glare ratings is a complicated subject and can really only be performed if the observer's point of view is known. So the data we provide is on the fixture. Once we have location data on the observer, here's the formula for calculating the unified glare rating. So that's a number that's typically expressed from 5 to 40, with the lower number indicating lower glare. Now, 40 would indicate discomfort glare, and I'm happy to report that none of our products, in fact, the majority of our products, are well below 30 on the UGR. But that's the information that you will get on our tables, and if you're a lighting designer, you would plug some of that information is based on your conditions, so reflectances, mounting heights, and so on, to get your UGR. All right, so primary criteria. Let's talk about what we're going to need when we do our basic layout. We're going to need light level targets. We're either going to say we've got this many lights and we want to know how much light is going to generate, or we have this space, so room dimensions, this mounting height, this is the target illuminance level that we want, the number of foot candles. We know our reflectances, we're going to plug those in. Finishes are not factored in this kind of basic lighting calculation software, but they can result in significant changes or have significant impacts on the lighting if you're relying on a wall to reflect some of that light and you happen to be shining onto a stucco wall. The majority of that light will be dispersed and will not actually be reflected right back, but at all kinds of acute angles. The other thing is occupant age. It's very, very important that you take your light level targets and factor occupant age into your equation, because someone who is 80 years old, 70 to 80, needs 4 times the amount of light than somebody who is 20 years old. So just, and there's a nonlinear sliding scale in between. The IES publishes that kind of guideline. And speaking of the IES and publishing guidelines, the Illuminating Engineering Society is an American organization that is now international. There are sections in Australia and other countries, Ukraine. But the association has been around over 100 years and has been the principal Western Hemisphere body to develop standards for light levels in all kinds of spaces: residential, commercial, industrial, military. There's recommendations for virtually any kind of space. Here's just some examples that I took out of a single page for foot candle recommendations, and you can see that they've got all kinds of metrics or requirements for hotels, offices, whatever industry you happen to be in. The IES has a guideline for the lighting that you require. And for everyone on this, if you haven't already downloaded the IES Ready Reference app, do yourself a favor. It's loaded with tremendous information, not the least of which are the tables for the recommended light levels for every industry. So you can simply click and select whether it's an interior or exterior, the kind of industry, the kind of space, and you will get the light level recommendations, so that when you go to do your layout and verify that what you're proposing to your specifier is good, you'll be able to back it up with some hard data. All right. Now there are, IES files are created for every single configuration, and Lightline happens to have a lot of different fixtures that can be configured for different outputs at different color temperatures, and all of those, remember, influence the output. So just looking at a 2x2 here, this might be a panel, it could be an edge. Yeah, it's probably a panel, and we have 30, 40, and 20 watts in 3 different color temperatures. So we've had to create, or we did create, 12 different IES files for just the 2x2s, and we have IES files for virtually everything. But what is a layout going to tell us? Well, it's going to tell us the most important information and the reason for which we're doing a layout, a basic layout, and that is what are we going to get? So in this case, we were using an edge with a 20 watt output at 3500 Kelvin, which produces or delivers 2200 lumens. We could have delivered 4200 lumens, but we chose 20 because we had specific targets. So we delivered 37-foot candles on the floor, which was tremendous, and 53-foot candles on the desk. And that's probably a little higher than many offices, but they were doing some color matching, and they wanted some higher light levels with excellent CRI, and chose the edge for those reasons. They can always reconfigure that and go even higher. So imagine the monetary savings, because they're also using much less power. In this case, this is our Lightline cafeteria corridor leading into the distribution center. We put in some funky edge 1x2 luminaires in honor of our open house celebrations last year for Christmas. And here are the results. The 1x2 is non-wattage selectable, so it's 30 watts. We selected 3500 Kelvin, so delivering 3400 lumens. Here's the grid ceiling mounting height. We used a 10-foot spacing. We did this because we didn't need very much light, but had we gone even further, our dark spots here would have been more pronounced. So we wanted relatively good uniformity on the floor. We weren't so concerned about the scallop. So we went to a 10-foot spacing and got 35-foot candles on the floor and 65-foot candles on the stainless steel counters. That's extraordinary, given how few luminaires there are mounted here. All right. This is something else that we've done recently. We've actually created an IES file for our edge luminaire, which is a lay-in grid luminaire. And instead of putting an acoustic tile inside, we put a 2x2 panel, one of our LED edge lit panels inside, and measured the IES file with both combined. And these are the types of applications that require high lumen, so 80 to 100 foot candles. Very difficult to achieve with conventional troffers or with conventional lighting. This gives you the opportunity to put out or deliver 9,000 lumens out of a 2x2 grid space. So very, very good efficacy for higher ceiling applications or industries that require higher lumens. And this was specifically for a pharmaceutical application where they needed 88-foot candles, and they wound up using 2x4s with a little over 11,000 lumens. So now we take a slightly deeper dive into actually creating a layout. And after that, so as I mentioned, we're going to raise our hand if we want to ask a question midstream. Laura will open your microphone, and you'll be able to speak with me directly. And if there are still questions at the end, we'll take those then. All right. So we will go to visual3d.com. And here you will find these utilities. Let me just zoom out so you can see the whole page. But down here are their free utilities. This software was this software developer was purchased by Acuity Brands, and Visual is an Acuity company. And so the one caveat I'll mention is that when you are using their free online utility, and we're going to go to the interior tool right now, but there are some other tools that you can explore on your own. Today we'll be covering how to use the interior tool and the wall wash tool and a couple of different hacks. So we'll start here with the interior tool. And what I've created, so the caveat is when we bring in the luminaire, you'll see why Acuity provides this software free of charge to some of their partners so that they can more easily bring in their products. I'll show you that in a sec. So we're going to start with a room that's 20 feet by 30 feet with a 9-foot high ceiling. Can everyone see this detail?
Yes, we can.
Okay. We're going to use standard reflectances, which for ceilings these days is 80. For walls, we're going to use 50. And for the floor, we'll use 20. These are known as standard reflectances. Typical white ceiling. With the walls, you're averaging because you never know if it's going to be white or dark. And floors with carpets and wood floors, tile floors typically suck that up. We're going to ask for 30-foot candles in this space. And we're going to select a product now to do that with. And here's what comes up when you add a luminaire so that you can start to do your calculations. This is Acuity's lineup of companies, all of the companies that they own. And under each of those companies, they have subgroups of the luminaire families. So if you are planning to use an Acuity product, it's very easy to do so. Otherwise, you have to have the IES file that you'd like to incorporate, and the IES file has the data which will allow this software to create a simulation of what things will look like in reality. So here I've got IES files in subdirectories sorted the way I want. So I'm going to take a Luna 4 Classic. This is the gimbaled version, 90 CRI at 3000 Kelvin. I'm going to open that file and we'll get some essential data here. Do you see that? So we know the color temperature, we know the wattage, 11.2. We know that the lamp lumens are 809. and the IES file name tells us some of this information as well. It also gives us a graphic view of the beam, the actual distributions. So we pop that in, and the first thing that comes up is a layout that has 24 Luna 4s. 24 Luna 4s to give us 30 foot candles. Well, that's excellent. What other information can we get here? If we click the little layout checkbox, now we can see what the spacing is of each luminaire, even the starting from the end walls. So we're 2.5 feet out this way, 2.5 feet out this way. We can do this to help with the plan view, or you can just snap to a plan view or the orthogonal view, or see it in elevation view from either side, but that's kind of pointless. The one thing that we might want to do here right now is maybe change our work plane. Remember I said that we measure on the floor, we measure on the desk, we can measure on a countertop. In different applications, the work plane is defined at different heights. So let's assume this is an office, and we'll say 2.5 foot work plane. See what just happened? It just added that little gradient right there. So now you can see the watermark of so now this is what we're measuring. So we were measuring 30 foot candles. Now that we've raised the work plane where we're measuring the lights by 2.5 feet, now we're getting 32 foot candle average in a 6x4 arrangement. If we had a grid ceiling and we were using downlights, we could still pop in the grid ceiling. It wouldn't affect anything, but I'm just showing you that in the ceiling type. And if you have a 2x4 ceiling, you can do the same. Notice we're going along the short axis. What if you want to go along the long axis? Change the orientation 90 degrees. There you go. There's your 4x2. Now, what if I change my criteria? What if I change from 30 foot candles and scrub that criteria and say that for this space, I can only afford to install 12 lights? So let's do that. So now we've changed the criteria. Let me get rid of this grid ceiling because that's just distracting. And have a look at what happened here. So we went from 24 to 12, and not incidentally, our foot candles dropped from 32 to 16. So volumetrically speaking, this is our average foot candles. And if we triple the lights, then we'll triple this number as well. That's how things work from this perspective. By the way, not sure if anyone has noticed, but what shape Luna did we use? We used a round Luna, and these are illustrated as square lights, yes? So down here, where we have all the light data, let's just select circular instead of rectangular. And you see what happens? Now our downlights look that way. And by the way, you can take screen grabs of this. You can copy and paste this information as an image. You can save it. If you don't want to see the room information and you just want to see the lights, that's fine too. Now let's do something interesting with this information. So we've got 12 lunas, and our work plane is 16 foot, is 2.5 feet, and we're getting 16 foot candles. Let's bring our work plane down to 0. Leave everything else the same. So now we're down at 15 foot candles. The light has had to travel a little further to get to the floor. But now I want to compare this fixture to some other fixture. Why don't we compare it to a slim? So we're going to browse. This time I have to go to my IES file directory for where I keep slim files, and we're going to select a slim for 3000 Kelvin. Notice anything about the distribution? A bit more of a blob, right? A bit more of a circle. There's not much focusing that into a cone shape, into a cone of light. All right, so we've just added our slims, and here's a direct comparison. Now over here, you can even see it. So here's your B results, your spacing, your foot candles. Anyone notice that we're only getting 8 foot candles with a slim 4 as opposed to 16, 15 foot candles with the directional source? So what does that tell us about the ability of a directional source, a regressed downlight, to push that light down to the work plane where we need it? If we were doing a professional layout using more sophisticated software, we would probably get much higher wall vertical illumination with using the slims, because they're just spreading all that light, scattering it in all directions. But that's our average on the work plane that we're measuring. So if we moved our work plane to, I don't know, let's move it to 5 feet, all of a sudden the slim becomes a much more efficient light source. Now you're delivering 10-foot candles, and that hasn't changed for the Luna. So at that, with only a 4-foot distance for the light to travel, the Luna is still able to deliver much more light onto the work plane than the slim. You can do this with any type of space that has 2 dimensions, that is rectangular or square. Once you get into irregular spaces, then you either have to start chopping it up, or you have to, or you would need to use more sophisticated software. But that's the little utility tool. Now from here, rather than jumping back to visual3d.com, I'm just going to go to their little shortcut and go to the wall wash tool. All right. So the wall wash utility acts slightly differently, but gives us point-by-point calculations when I show you how to do this. So let's create a wall. So remember, this is a wall wash tool, so we're going to create a wall. So the wall can be 10 feet by 10 feet. Or just for giggles, let's make this an 8-foot high wall, so representative of, let's say, a feature wall. Now, let's take out the constraints. Let's take our setback to 2 feet. Remember, this is a wall wash. And let's select a track light. Let's go select a Flex series track light. How about this guy right here? They're 3000 Kelvin, 40 degrees, Flex 15. Excellent. Okay, there's our beam distribution details, our lumens, 1268 lumens. Nice. All right. So now let's see what's happening from our profile view. Our setback is there. Ah, we don't have a quantity. Let's add 1. And there we go. So let's have a look at what this looks like from the side. Bear with me a sec. All right, so this is a track light. It's mounted on the ceiling of an 8-foot wall that's 10 feet wide. And whatever distribution, whatever light is hitting that wall right now is incidental, because the track head is pointing straight down. This is when we go to the actual fixture parameters and change things. So do we want it pointed straight down at nadir? No, we want to point it into the wall. So let's start by pointing it into the wall 15 degrees. So that's tilt. So this is telling us that we are now pointed 15 degrees into the wall, and the center of our beam is hitting at 1 foot above the wall. And here's what it's done to our distributions. 44 foot candles in the middle, 44.2. Let's change a few more things around. Let's go back and increase our tilt angle to 45. It's a track head after all, right? 45. Now we're aiming into the wall. We're hitting the wall at 6 feet, only 2 feet down. Probably have a huge hot spot. Whoa, 202 foot candles right there. So that's not a realistic mounting for a track head, right? 2 feet out. So let's bring that out 5 feet or 4 feet. So this is our setback. We'll move our setback to 4 feet. See what happens now? Now, not only are we going to have less intensity right in that middle, but we're also hitting the wall dead center, if that's the objective. But here's what it looks like point by point. Here's what the entire wall looks like rendered. Here's the same view that you can achieve with a heat map. Or you can just get your point by points. So there's 5 different views here. This view really confirms for me what I can do and what the setup looks like. This gives me all of that granular detail, my setback, my space on the wall, etc. And if I wanted to see what 3 track heads look like for better uniformity, let's just change our quantity to 3. That's much better, right? So our averages have improved. Our uniformity has improved. Let's look at our heat map. Oh yeah, much nicer. Now I can change all of these ISO lines so that they reflect, so that the shapes look better for what I'm trying to achieve. So let's go 15 here, and let's go 12 here. The numbers don't matter, but you'll see what happens to the change here. Now let me bring this. Anything that's 15 over? No, it's 50 over. There we go. Okay, so you can really customize this to show your client what things are going to look like. But here's the hack. So here's 2 hacks for you. Anyone that's still with us, 48 minutes in, will get this freebie that I learned from Greg Subisak, who developed this software. And here we go. So taking it to our setup view, I've got an 8-foot wall. I'm going to make that a 10 by 10 wall because I want to gauge something different here. I'm going to move my setback to 8 feet. This now becomes my mounting height. You'll see in a second. And then I'm going to move my suspension length. Since I'm 10 by 10, I'm going to suspend it 5 feet. 5 feet. And I'm going to tilt it. Look what's happening. Are we there yet? Yeah, it's starting to happen. Okay, luminaire normal points below bottom vertical surface. Sure, but that's because we haven't aimed it in yet. 90 degrees. There we go. So now that's a track head, but I'm going to plug in a Luna in a second and show you. But there's your diagram. There's your plot for a single downlight. So you know exactly what your mounting height is. We've said that that's 8 feet, so we've used a setback distance of 8 feet, right? So if we could flip this 90 degrees, then we'd be looking at it correctly. But because we can't, this is how you cheat the software to get what you need out of it. And then I'm going to bring in another light. Back to our Luna. Ooh, yes, let's use our new Luna 3000 Kelvin 18 degree. Anyone that wasn't aware, we have a single Luna configuration with a tighter beam for higher ceiling mounts and for outdoor soffits. Works beautifully. So I've just brought in a new light, so I have to do the same things to the light that I did earlier to the track head. So 90 degrees for aiming in, orientation's fine. We're not worried about light loss factors at this point, but if you ever have to plug in a light loss factor, you can plug it in here. Our suspension length is 5 feet. And now we have a downlight that is behaving or a track light that's behaving like a downlight. But that's what we've done. We've tricked the software into giving us a view that we wouldn't otherwise be able to get in terms of point-by-point calculations. And one last hack. So by the way, now that we've got the track head and the downlight positioned more or less the same way, the downlight, the track light, which delivers 1268 lumens, but only has a 40-degree beam spread, look at how much less light it's putting on that surface than the Luna 4 with 18-degree that only has 1067 lumens. So the track light has more lumens, but a wider beam. The Luna has fewer lumens, but a tighter beam, and this is the effect that you get. This way or this way, and then you can take a screen grab and share that. Moving on to my last little trick here. Let's create a corridor that's 6 feet wide, 30 feet long. We're going to use the same type of setup as we were on the wall, only now we have to center our light. See here? So our setback is fine because that's our mounting height. Now we just need to put this light at 15 feet. So the suspension length has to go from 5 to 15. And now our light is in the middle. Remember, this is a corridor. Orientation, let's see what this does. Nope, just orients the source. Okay, so here's your corridor, and you want how many foot candles in your corridor? Right now we're achieving 4.8 with a single light. Let's put in 5 lights, spaced. Ooh, that's the problem. Our corridor's sitting like a high wall. 30 by 6 instead of 6 by 30. There we go, that's better. So if that's 30 by 6, then now we have to adjust our suspension length to 3 because we flipped the axis. And that's better. So there you go. There's your wall. There's your point-by-point calculations. By the way, the red numbers always indicate hotspots in a lighting layout, and blue numbers are always indicating the lowest foot candle reading. So pretty cool, and you can change this number. So if you want more than 23 foot candles average in your corridor, you can change this number. Or if you want to reduce it to 15, just change it from 5 to 4. You can see that the uniformity will suffer because now you will have pools of light. Remember, we're using an 18-degree Luna for this. If we want to use the 40-degree track light, it'll probably be more uniform. Let me just set that in the middle of our space, and there you go. So there's your uniformity. Anybody that's been looking at the side here, you'll also see your max to min and your average to min. This is the type of data that full-fledged software gives you, that this kind of utility is providing. So that pretty much wraps it up for the hands-on demo. I'm happy to have questions.
Thank you, Eric. Again, if you guys do have questions, you can raise your hand so I can allow you to talk, or you can still submit through the chat or Q&A.
Well, if we don't have any questions, then I guess it's time to bid everyone adieu. But before we go, Laura, we've got some other great sessions coming up next week, don't we?
We do. So again, we're hosting our webinars on Wednesdays and Fridays at 11 a.m. and 2 p.m. Eastern Time. So next Wednesday on May 20th, we have Deborah Gottesman presenting tools for creating ideal office environments. And then next Friday on May 22nd, we have Jake Summers presenting how to light grocery stores. So again, if you guys want to see more of the webinars coming up or to register, you can just visit the our landing page website, so lightline.com, and you can register from there. Thank you so much. Have a great weekend.
I'm not ashamed to promote Deborah's webinars. She's an unbelievable lighting designer. She's done 2 CU accredited presentations for us, and this this quickie that she's going to be doing on designing lighting design for offices is not to be missed. Check out our website, register for all the webinars. They're all pretty amazing. Certainly the one for how to light grocery stores, if you're in that business or if you touch that business, do yourself a favor, catch Jake's advice on that. He's been in our business for a very long time and is a very knowledgeable guy. Thanks, Laura.
Thank you.
Wonderful weekend to all. Shabbat shalom.